Let's see. Hmm. What's the chat at? The chat's not showing up. Ooh. Oh, there you are. There you are, chat. Oh, yep. Going back doing the whole Zig Fighting Game. How's it going, Backdrift? Thanks for dropping by. Just thinking that I want to do things more than work. Last year has been pretty much nothing but getting work done, so I'm trying to do my best to kick other things off. And I want to get back in the swing of programming in Zig, which I haven't touched for any purpose since the last stream that I did, probably back in December 2022. Man, I can't believe that much time has passed. It's wild. Yeah. But yeah, I mean, I'm just gonna kind of like look over what I have and where we come from and see what things needs to be done. There's a bunch of obvious things like the input switching depending on your side and such that I'm gonna work on today probably. Do little things a little less formally than I did in the past for the time being, but then get back to like planning things at some point. Usually I'd have the whole planning step and then going forward with the implementation after that on these streams. But today I'll just do something a little more off the cuff, ad hoc, as you do. Like right now, I'm looking at the walk. I think the walk speed's too slow, so I'm gonna speed up the walk a little bit to like 3,000 units. That feels better. I think it was a little slow. Jump speed is very slow, so let's go ahead and increase that jump speed rate. So is there a jump forward? Yeah. So we have this is our jump struct that just has these callbacks, right? On like start, on update, on end. On update, well, we set the jump forward speed at on start, so let's make it a little faster. I think 2 is better. Feels a little better. Jump forward. Ooh, sorry. Yeah, the inputs are still reversed. Back. The jump defair is a little floaty, to be honest. Let's just speed up a little bit to 2,500 units. Whee, whee. Okay, it's a little better. I still think jump is a little floaty. So let's just increase our acceleration a little bit to 400 units per frame per frame, basically. Oof. So a little better. We want the jump height to be higher, so we need to set the initial velocity to be higher. Luckily, the build speed is so fast that I'm literally just like rebuilding the game every time I make these changes. Whoop! There we go. Too much. Too much. Let's meet halfway. See what happens. Hope hey, can you guys hear us? Hear me pretty well? If not, let me know. A little high, a little more, a little floaty. Let's increase a little bit. See how that goes. Yeah, I'm gonna increase the gravity some more. That's what I just did. Just tune it to a point where I'm like more happy with it. Ooh. Okay. Let's bump it up a little bit. My voice is only coming out of the left speaker. Give me a second here. I don't know anything about this stuff. Give me a second. Properties. Oh man, I don't know how to control that in Discord. Give me a second here. Is it just my voice or the music as well? Okay. The mix right now is set to in the middle, so that's very strange. Hold on. Huh. What if I just set to mono? Maybe that fixes it. I'm gonna set it to mono and see what that happens. If it does anything. Oh, the music as well. Whoa. Okay. Thank you, OBS. You know. I don't know why it's doing that. If anybody has, I just upgraded OBS, so maybe something to do with that. I don't understand. Yeah, I'm just gonna set it to mono, see if that fixes it. Yeah. Okay, yeah, just we'll have to deal with mono for now. Because I don't know what OBS is doing. Okay, because I didn't change anything intentionally. Alright, that's a little better, but forward jump, You know what, I tend to I want to go extreme. When I'm doing these things, I like to like shoot past the point where I want to be, right? And then you kind of can back up. Easing into the perimeters you want in games, I think, is kind of always the worst way to go about it, right? If you don't go as extreme as possible, you don't know where you can go. You don't know how good it can get, right? You don't know how good it can get until you go past what's good. Yeah, and I think that's better. Even just honestly, like, even that's pretty good, feeling wise. So I'm gonna keep it there. I think that's a pretty good place. And I'll go ahead and what is it? Common states. Add that and commit that just to say, hey, adjusted the jump. There we go. Wait, actually, did I? Yeah. Yeah, just doubling is like it's like the old binary search, right? You gotta like jump to halfway point, see where it is. If it's not there, jump to the middle point. Jump to the middle of that. If it doesn't work, yeah. Okay, one thing I want to fix here is the right now the input. If I hold, do I have? I forgot. Do I have an input display or not in this version? I have some debug stuff. I have this. No, I don't have any input display. But when I'm on the other side of the character, walking, when I hold back, I'm actually walking forward. We don't want to do that, right? So what we'll have to do is, in our input checker, we'll have to look at the direction the character is facing. The question is, where was the input checker at? Where are we using this input command? It's at a state transition, so right, it should be in our common state. So my guess is it should be walking forward. If you look for where the walking forward transition is, ooh, I don't want to be there. I'll turn on music here. It's a little intense. Okay. Yeah. By the way, since we're kicking this off, anybody who's dropped by after so long, I'm very much appreciated. Feel free to, hang around, chat, ask questions, anything, related to, even if it's not fighting game development, right? If it's just game development or life questions, go ahead and ask, and I'll do my best to give a response. Okay. Yeah, so I was just looking at this walking forward, because I want to make sure that when you press, the forward direction, meaning we don't want to check left, right, we want to check inputs as if they were forward and back and give the appropriate action. So obviously the forward input flips when you change sides. So that's the thing we want to handle. So we have a transition of walking forward somewhere, right? Oh, and here it is. That's in the walking back. This is in the common transitions. So you see we just have input forward. The problem is our input forward command right here. It's set in one of our updates somewhere, right? Here, I think. This is our main game loop, and we say if button down left, we always assume. Oh, so inputs, we do have a flip input, but the issue is, oh, well, actually, this is interesting. So I thought we were checking facing. I thought we already implemented this. So why is flipping not working? Oh, is it because the keyboard? This is gamepad. Well, yeah, let's make sure we're doing these with the gamepad. Okay, we got that. What about our input for a keyboard? Interesting. Where was our keyboard handling at? This is for our debug stuff. Okay, let's just do key something. Well, D is forward. All right, yeah. So we're not doing flipping on the keyboard yet. So I think I was using pad during development. So let's go ahead and support the keyboard here. So right. So we could just do, I think. let's double check. I just want to make sure this is what I want to do. Yep, that's what I want to do. Okay, so just do that. And flip our inputs depending on the direction. This is normal here, so we don't want to do forward, we want to do back instead. We want to do the reverse of that for back. Right? Yeah, there we go. So we want to do forward and then back. I think that's it. Let's go ahead and save. Oop, I can error. Ooh, save. Do I have an error though? Error undeclared. I did for flip input. Oh, that's right. Sorry, I should put that up here. What does it not like about that? I don't know if that's an actual error or just the intelligent sense thing. Oh, first time chat. Let's see what's going on here. Hey, Repugnim Tharns 3. This is this is a bot. Okay, so goodbye bot. Let me do. How do I get rid of you? I should be in admin here. Mod view. Give me the mod view. And yeah, I know. You need to go away. How do I get rid of this guy? Pin. What happened to Twitch? There's like no easy get out of here option. What the heck? I don't know anything about Twitch anymore. Chat will be cleared of anything. I don't know anything about this. How? Come on. Thank you so much. Click on the username and then ban them. Goodbye and report. Spam. There you go. There you go. Goodbye. Spam. Selling stuff. Okay, I don't know. Goodbye. Hi. See you later. Okay. That's annoying. I don't have that many viewers. Why do I get spam? Okay. Oh, I got an issue here. Oh, entity. I don't know what the entity is. I have to get the entity number, right? Oh, we're just assuming 0 right here. So keyboard only works for player 1 right now. I forgot about that. That's all fine. Whatever, you know. Yeah. Cool. Yeah. Jace, thanks about that. I'll check out Nightbot. Thanks for dropping by the way. Appreciate it. Okay, so I think on our keyboard we have flipped inputs. It's working. Yeah, there we go. Flip inputs working now. Sweet. Yeah. Let's commit that because we want to commit our code. Be good boys and girls and commit our code and properly comment on them. So yeah, let's add that. And if we want to be really proper, we gotta check our changes, right? And everything looks good. I'm showing you how to be a proper game developer. This is how you do it. Review your changes before you commit every time, right? You know, and you just double check to yourself. Okay, well, I was intending to flip the input, yes, and we're player 0 on keyboard always, so that's fine. And that looks like that's it, and we're good. You know. Oh, I'm not happy about that extra line there. It doesn't matter. Whatever. Remove that. Oh no. Oh no. It's fine. I have to undo this. There we go. We can do that. Now we can add it. Cool. Okay. Go ahead and commit. Let's say supported flipping inputs depending on facing direction with keyboard controls. Yeah, there we go. Commit. Now it's committed. Actually, I should push it up to the server. Okay, there we go. We are good there. Sweet. Okay, what are we gonna do next? Well, let's play the game a little bit and see what we want to change. I do have a big list of stuff from over a year ago that I need to review, so we could do that as well. Okay, so we have pushing. We can push each other characters around. Sweet. We can hit each other. Whee! Oof. Oof. Okay. Oh, I think I see a bug here. I think I almost had it. You see that? See what happened there? Let's see if I can time it right. Like if I hit it like the frame before it touches the ground, the character transitions the landing. Up, you see that? That's actually a common bug in fighting games. And this is kind of one of the reasons I like having these kind of streams that explain to people. If I can hit like, oh, there, you saw what happened, right? Let me turn on the hitboxes. So you can see, like literally, if I can get the one frame before touching the ground, the character will transition on that same frame to landing. So actually, it's kind of tough to get. I could time everything out because I know how long the startup is. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. It's all the way in 9. Okay, so if I activate it 9 frames before touching the ground, then we can figure out exactly when to press input. So press up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was 30, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 50, 1, 2, 52. 52 minus 9, we got 43. So, ooh, okay, it's going to be annoying to count, but we're going to go ahead and do it. So press up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. That should be right. It might be off by 1. That often happens. And also, am I pressing the attack button? I think I am. 1, 2, 3, 4, 5, 6, 7, 8, 9. I did not. Oh, that was not the that was not the attack button. That's the attack button. Okay, let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oop, messed up. Do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can just watch the number here, actually. Okay, 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Off by 1. So we actually want to do 1 frame earlier. Okay. Don't you love the off by 1 errors? So here we go. So we're on frame 33, add 40, so 73. So let's just go up to 72. So 70. Let's go to 73, then add 1. I think that's what. No, we want to add 2, right? Yeah, we want to add 2. So 73, 75. Okay, let's just go ahead to 75. We have this game frame at the top that lets us like track exactly where you want to be. So 75. Let's try. Okay, we got it. Last frame landing. And we're going to see this bug where the character lands. You can look at, notice there's hit stop on both sides, right? If you look at the bottom here, you can see where it says hitboxes overlap, attack end, which means we transition out of the attack, which means we're going back to standing here, right? We don't have a landing state, so. And then we're in hit stop now. But the character has transitioned out of their attack state. What we really want to see is when the attack, we want to keep the attack overlapping so that we can actually, visually confirm that our hit made contact. The issue is, normally you would see that, but because our jumping state transitions into landing before hit stop is activated, we have that problem. And there's several solutions we can go about implementing to solve this. But the issue I would like to point out is a lot of games actually maintain this, what I would consider a bug, including Marvel vs. Capcom 3. I think the Alpha series has this issue. Yeah, I don't like to keep this kind of thing in my games because I prefer that when you hit somebody and you have a chunky hit stop, you want to have that like impact frame visible, right? You don't want your character suddenly to transition out of it. It also can lead to all kinds of like exploits and gameplay bugs, like if you have some kind of thing that resets like jump count when you land. You could potentially exploit that, or like a mode, like I think Alpha 3 series, or is Alpha 2? I think it's Alpha 2, where you activate. I can't. I think top of my head what the name of the mode is, but there's like a counter or something that resets, something to do with the combo counter like resets when you land, but because you can like interrupt the landing, it's a slightly different issue, but yeah, things like that do pop up. Okay, Jalapeno Bomber asked, hello non-FG off-topic question. The American game dev and tech scene have seen a ton of layoffs. It doesn't seem like that's a thing in Japan, at least from a quick Google search. Is there any worry about this stuff spreading? Well, funny enough, my company did go through layoffs, but it wasn't related to. Well, it might be related to the current situation, but we only laid off people that were like still kind of on their evaluation period. And yeah, I think so unfortunately, like what happens is things you think are going to get funded don't get funded, and you just don't have the budget. And I think it's a little different situation than a lot of other companies which needed to show profit, right? They needed to show to their investors they had growth and profit for this year. So the easiest way for them to do that when the market isn't growing is just to lay off a bunch of people, and it's very unfortunate. Now Japan's different. The companies, of course, they want to show profit, but they can't easily lay off people. There's a bunch of laws that prevent that. If you can pay your people, you can't lay them off. There's something called restructuring, which you've probably heard of in outside of Japan as well. There is corporate restructuring, and they'll kind of use that as an excuse sometimes to lay people off. And it's even to the point where like they don't even use the word layoffs. They say restructuring or ristora when they mean, oh, I've been laid off. But it doesn't happen as much here again because the laws kind of prevent it. It's not, there's no like at will contract stuff. It's here. It's all like lifetime employment unless otherwise substantial circumstances lead to you needing to be laid off, like not doing your work for a long time. And even until then, like if you're not doing a job or whatever, you've kind of pissed off your boss and they've ostracized you, start getting ostracized, your coworkers stop talking to you because it kind of hurts their position, and they'll give you like shitty work or boring work or no work at all, so you just have to sit there at your desk all day, which is not psychologically great. Not a great thing to do to people. And yeah, and they'll do that until you quit instead of actually firing you. So yeah. Anyway, yeah, going forward, cool. Well, yeah, we have this bug, and I would really like to fix this bug. So how is going to fix this bug? Well, the first thing to recognize is the fact that, like, well, even the game runs at 60 hertz, basically one game update per 1/60th of a second, there is still internal execution going on, right? Like, at some point we said hit stop on characters. At some point we transition the states, and the order really matters here. And in this case, it seems that several things could be happening. And since I haven't looked at this code in a while, I'm just going to like guess what's happening here. It could be wrong, it could be something else. But the general idea is, either collision is detected before state transitions, and that's probably likely because we do apply a reaction state transition after a collision, which is intentional. I wanted the reactions to not have a 1 frame delay. If I didn't actually do the state transition after the collision events occurred, you would have to wait the entire next frame to see the collision occur. So it does occur on the same frame. The state transition does occur on the same frame as the collision event. That being said, I thought I had set up the character normal input transition to occur on before the collision event, and it looks like in this case, what happened was the transition happened after the collision event. So I need to see what's going on. And when I say transition, I mean transition to landing, right? We can look at here in the log here. We have attack start, right? Push box overlap, push box overlap. I hope you guys can see this. And hit boxes overlap finally, which means that attack box overlap the vulnerable boxes. And but then you see attack end and then standing start. This is exactly where player 1 transitioned into landing. So that's not what we wanted at all. So let's go double check to see where our landing transition occurs. Now, one way to fix this would just be to check to see if hit stop is active and not transition. Don't know if that's the best way to go about things, but it may be something we have to do. Okay, and it is a solution I've seen. in games. It's a check to see if you hit stop and prevent transition in that case. But hypothetically, you can just do the state transitions before collisions and for the normal character controls, and you shouldn't have an issue, right? Because, oh, I should point out something too, is that we should not transition at all when there's hit stop. Sorry, let me correct myself. We should not transition the character attacking when there's hit stop occurs. We have to transition the reacting character, otherwise we won't get that nice hit pose, right? They'd be stuck in their idle state, which is not good, or whatever state they're in, whatever previous action and animation they're in. So yeah, where's our state transitions? I know we had like a state machine here, and we have a transition to state that's called, we have jump standing. Okay, go back to idle, that's fine. So we have our state machine processor here. Going through, update state machine. Well, we just have to review this a little bit. So I think, do we not check hit stop at all here? Yeah, we do have a hit stop check. Advance the timeline when there's no hit stop. Yeah, okay, it's advancing the timeline, it's fine. But do we not check hit stop? Let's see if we actually check hit stop and prevent transitions. I thought we did, but maybe we never did. Okay, update physics. Okay, don't update physics when hit stop is on. That makes sense. Hit shake during hit stop. Well, that's okay, that's fine. Reaction systems there. State machine systems there. So it looks like the only thing we did was prevent the timeline from updating when hit stop is on. Oh, backdrift. Do I understand? It's late out there. Get some sleep. You can always watch the archives. But yeah, thank you for dropping by. Sweet. Okay, yeah, so one thing I want to see is, so the question is, like, where do we want to actually prevent transitioning when there's hit stop? Okay, I don't want to like prevent other things that may want to update during hit stop. Obviously, frame elapse and stuff like this shouldn't happen. Timeline update shouldn't happen. You know what? So handle return idle. I know that part's there. So that's all that does here. Perform state transition. Okay, so the transition is just right here. Let's just double check that's not happening. Let's make sure we're not actually preventing it inside the function. If we're inside the function, that's fine as well, but to do transition. So if there's a transition, perform state transition requested. Okay. Let's just prevent from calling this entirely if there's hit stop. So let's go here and grab our hit stop and only do this when hit stop is less than equal to 0. Okay, there we go. So that should prevent that from occurring. Okay, so let's do this. Now I'm going to check our bug. check to see if our bug's been fixed. Yeah. I'm a little annoyed because I thought I had set up the transitions to only occur before collisions. Maybe I was wrong. Maybe that's now how I did things. Didn't I have a diagram showing exactly like what order of our systems were? I thought I did. I'll have to go back and check it later. Anyway, where was that state machine update? So we're doing it once. That's a test. Okay. We're doing it once here. That's a test as well. I don't want to do that. Oh, here we go. So we are action system, and the action system is called here. Okay, where's the action system called? Oh, no, we actually called the action system last. So actually, on this project, I did not actually set up, I have the state transition. I have the transitions happening very, very last in the, in the game update. That's the cause. This is the exact cause. So one way to fix this is to move it up to an earlier, to make it execute before our collision reaction system. I don't remember why exactly I did this. I think the reason I did this was because I want to make sure that reactions execute or transition into after a hit But actually, what I typically do these days is I split up the transition for reactions and transition for player controls to different stages in the game update. But actually, this is good because I like to make these common mistakes and correct them for demonstration purposes. But let's go through our first fix just to demonstrate it, right? Just to demonstrate how it can fix our issue. So, but I don't think it's the ideal solution. And why don't I think it's the ideal solution? Well, you don't want to litter your code base with full of these, like, it's hit stop on, it's hit stop off, right? If you can kind of stage your game properly, you should never run into those issues. Also, there is another problem, whereas it's not necessarily a problem, but if you have okay, let me give you an example. If there's a one frame startup move, right, where you press a button and the next you do one tick of the game, and that collision is active that frame, right? Well, it won't hit that frame; it'll hit the next frame because the collision check happens before the state transition. So we could solve that they could also solve that problem by moving the action transitions to an earlier stage of the game update, and before the collision check and before the reaction check. So that actually solves two problems, right? And in game development, as much as possible, you want to, if you have a simpler solution that solves multiple problems, then yeah, that's the one you want to go for, right? The goal is kind of always avoid complexity. Okay, so I'm going to count to an even number here to make things easy. So we're at 90. Let's just go to a nice even 700, so that we can now easily, what are we counting to? We're counting to 42? Okay, let's count to 42 here. See if it fixed our bug. Okay, let me attack. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it still ticked one frame. But you noticed I didn't transition. The physics updated, but I didn't transition. And this is what I'm talking about. We just noticed another bug there, right? We only accounted for the transition by adding the hit stop check, but we did not account for the physics still updating. So just to be clear, I just want to demonstrate it one more time what I'm talking about for documentation purposes. Let me count up to an even number again. A nice power 10. Okay, so we need to count to 42 again because that's how many frames we need to go through. So we have a 9-frame gap to account for how much frames are left in the jump. Okay, so yeah, let's just do that. Go to 42. And I'm going to start the attack right exactly 9 frames before we land. Okay, do it again. 1, 2, 3, 4, 5, 6, 7, 8. Next attack is going to be the active attack, and it's going to hit that frame because that's how our our staging works. There we go. So the attack is overlapping now. We see the overlapping attack. And then we'll update one more time, and we're going to see hit stop on both players. But the physics is going to update on the player number 1. And he's actually technically on the ground now, but as you see, hit stop is 10 on both sides. Hit stun over here on the right side is 25. So he's in a reaction. Both characters are in hit stun. We didn't transition, but the physics updated. So that's the bug I'm talking about. So step number 1 was great. It was a working solution for our initial problem, but we want to have something that solves all problems. So I'm going to go back and undo that change that I made previously, checking for hit stop here, right? So we're not going to do that. What we're actually going to do is, the current plan is to move the action transitions to an earlier stage in the game. So we're going to take this out, move it before collisions. Okay, I don't know. I guess I don't return errors on action systems. That's why I don't have a try. But let's see. So that will work, but the problem is we won't have a reaction. The reactions will be one frame behind now, and we need to solve that problem. No, I don't want any action that has hit stop to allow physics to be updated. I mean, in the future there might be an exception, but I've almost never encountered an exception where I want the physics to continue to update when there's hit stop. Yeah, it's really weird to have hit stop when you're landing. I mean, some fighting games have that. I just think that's just kind of like a issue of, oh, it's always had it. It's kind of tradition. It's left over. Again, like Marvel vs. Capcom 3 has this issue. Um, is the game running? Oh, it's already running. Okay, sorry. Oh yeah, if it's just ground the whole time, that's not an issue. Okay, so let's turn on the hitboxes real quick. Oops. So you're probably going to see a 1 frame delay. Overlap here. So no 1 frame delay. Did I already account for that? So we have hit stop, hit stun. Huh. Cool. Give me a second here. Did we already account for that in the reaction system? Do we have a transition? Oh, we do have transitions, don't we? Oh, sweet. So guarded. Cool. So we don't even have to deal with that. We've now solved that problem. I don't know the original reason to actually I may have changed this, but let's see if it solved our bug. So just to reiterate, we don't need to actually add transition to reaction to get same frame transitions to reaction, same frame transition to reactions, because it occurs after the collision. The reaction system executes after the collision, and also the action update occurs. The player-controlled action updates occur before the collision system is updated. Oh, the collision process occurs, and so we can have literally update this frame. So say we have a frame 0 active attack. As soon as we transition into that state, if it's active, we can have a hit. And actually, I should demonstrate that just for fun. So what is our attack called? I think it's called attack. Well, before we get through that, I just want to demonstrate that we fixed this bug. So the change did in fact fix this bug. Okay, let's go back to a nice even number. Oh, I messed up. Yeah, go ahead. Okay, there we go. So I'm going to count to 42. Again. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Active. And you can see both the character has paused in midair and is not transitioning to landing. And both in hit stop at the same time. And now we continue on. Sweet. That's what we wanted. So just to demonstrate, I want to kind of show you what happens if we have a 1-frame active move. Right. We have character data. Isn't character data? What do we use Zig files or did we use JSON files? I forgot. Yeah, I think we use JSON files, right? Where did I put what did I put our game data? Is this one is in here? I think that's it, right? Yeah. So, well, that's not the right one. Hold on. Where's our JSON files? Test character 1, that's it? Okay. Also our assets, that's right. I forgot about that. Okay, do we have attack? Yeah, so we have attack. Whoops. Let's do a standing attack. Oh, here we go. I think it's a standing attack. Right now it starts at frame 8. Okay, we're going to start at frame 0. What happens now? Okay, let's do this. So, whoops, turn on hitboxes. So it's instant, right? You can see right here on the first frame here is active. So what we expect is it's going to actually cause a reaction instantly. Okay, let's do it. And as you can see here, both characters have hit stop. Hit stun is instantly activated. And you saw a little bit of a shake here, right? So it's exactly what we wanted. Works perfectly. Let me undo that change and go ahead and submit these changes that we've made to the game simulation. Okay, made it so the action transitions occur before the collision. Okay, cool. That's done, that's done. That's a cool bug that we fixed. And it's a very common pitfall that fighting games fall into. Honestly, I think it's like one of the most important. I'm not going to call it. I'm not going to call it a theorem, but it's a common pitfall fighting games have. It's one of the most important things to be aware of, right? The staging of when you execute your game systems is so critical to like prevent these kind of bugs. And if you do it nicely, and if you kind of follow this plan where you have like your character control state transitions occurring before collisions and reaction updates. Oh, sorry, reaction transitions. Then you can prevent a lot of these bugs. A lot of fighting games only have like one place where they do state transition. They don't like separate what character control from like reaction. So they kind of force everything into the single place. And I did this years ago, like when I was working on Fearless Knight, and that's how I encountered these kind of issues. And I've seen them in other games as well. I'm pretty sure that it's caused by this, exactly this. So I've kind of come up with this scheme now that we have like, we stage it exactly like this, right? And I can show you here, where we do action system update. Then we check for collisions. Then we check for any kind of reactions to follow up with. And I think if you follow this scheme in your fighting game, and again, it's down to taste as well. Some people want to like preserve that old like retro kind of slightly jankiness that you get out of alternative fighting games, and that's fine. If that's what they want, more power to them, right? But for my games, this is kind of how I prefer going about things. By the way, how are we looking on time? I don't know how long I've been streaming. Oh, it's not even an hour yet. Cool. Yeah, we can just sit back and check. What I mean by staging. Okay. What I mean by staging, really, I'm just talking about the order of when things happen. That's all. Right? This is our main. This function is our per tick simulation. So every time the game updates, which is every 60th of a second, right? 60 hertz, 60 times a second. This function is called. And then we call several systems, like we update our input first. You always want your input to be updated first. Nobody wants their input to lag for one frame, right? So you always want to process the inputs as soon as possible. So that's the first thing that always occurs, right? Physics, we can get to physics, but I tend to run physics first. But then we have the action system, which handles all the code related to action-specific behavior, along with transitions. All right, and the reason that has to occur after physics, right? So there's a dependency between these two. The reason this has to happen after physics is, for example, like if you're landing on the ground, you don't want the character to partially penetrate through the ground, right? You want them to instantly go back to zero. You want to make sure they're standing on the ground. So if you have like a transition from jumping to a landing action, you want to happen in the same frame. that physics detects they land. So that's why that's here. So often you'll find, if it's not clear, like what orders you make things, look for those kind of dependencies, right? Say, okay, well, I want to check to see if the character's landed, so we have to actually run the physics update first so that we can see that they've actually gone through the ground. So that's like an example of this kind of order dependency that pops up. Okay, and the bug we just fixed was an order dependency issue, right? Some order dependency issues just result in a 1 frame delay. Like if you check your collision at the very end of a frame as the very last process you go through, but you don't update reactions until the start of the frame, well, you have to do an entire wait until you do the next game tick, and then you can run the reaction transitions, and then finally you'll see um, the actual animation play out for that reaction. In the meantime, before that tick, well, the character's just sitting there in their idle state or whatever state they were in at the time, right? And the player will notice that lag, right? And if you start introducing these kind of like 1 frame 1 frame latencies all over the place, and it adds up, and it leads to like maybe the player doesn't know necessarily what the issue is, but they'll start to feel things are a little off, and sometimes that leads to bugs as well. Okay, cool. So honestly, that was the main things I wanted to do for the stream, just to kind of kick it off after a whole year and fix some things just to see where we're at. And I think we're in a good state, right? We now have push collisions. We have these green boxes that let us push characters around. I think this is the last thing I worked on. We fixed these 1 frame. Sorry, we fixed these 1 frame issues related to system dependencies. Sorry, order dependencies, and I fixed the keyboard left-right issue. So that's pretty good, I think. Oh, you notice another bug here? You know what? Character fell through the ground. I wonder how I trigger that. I can speculate. Oh, did I not undo that change? I thought I did that 1 frame that 1 frame startup move. Okay, I think I undid it. Okay. But I think y'all saw it where the character fell to the ground, right? You know what? Let me check something. Just as speculation. What happens if I go 1 frame extra in that update? Well, actually, that's not an issue because because the active frame will never come out. So what I was thinking would occur would not occur. I'm getting, well, right now, you notice I'm actually just holding the input. I'm not pressing it a bunch. We don't actually have an active. We don't have a difference, but for checking whether or not an input has been pressed or it's held. That's something I haven't done yet. So that's probably something I'll get to as input buffer related stuff on the next stream, because that's important. Right now, if you just hold the button, you'll just keep triggering attack. That's not what we want. We only want to do it when you press. Yeah, so I fell through. Anybody have an idea of how that could have occurred? I know I was attacking. But it might have just been one of those like weird things where like, by the way, you guys know it's another bug though? When I land, I'm not instantly changing directions. This is something else to discuss actually. So what should happen when you land on the other side of the player? Should you instantly turn around to face them? Well, this is another thing. It depends on the order of how things happen in your game, right? If you transition out of your landing into an attack, and attacks just assume they're going to face the direction the last action came out of, well, then you're going to have issues with like this, right? Where I'm attacking the wrong direction and continuously attacking the wrong direction. It never corrects. One thing I like to do is to correct direction when an action's ended. A lot of fighting games do this. Every time you transition out of state, do a check to see if you should flip. Okay, so we have this like flip state, right? A flipped flag. Well, that's only drawing, sorry. A facing left is what it's called, sorry. Which is what I name it in my recent games. So yeah, so where do we update facing left right now? Well, it looks like the only place we updated is here, in the physics, in the game loop. Whoa, that's an initialization, sorry. So that's initialization, and then we flip it. Flip to face opponent. So this is the function I did make. It's a utility function. Where do we call this? Okay. Call in several places. So we call it on directly in the actions. So the issue here is we're assuming that we're going to go through the idle state, the standing state, but we don't, right? We don't go through the standing state, so we never correct for this. So one easy way to solve it is fix it on landing, right? But the issue there is, what if we don't go through the landing state? What if it gets canceled out? So one thing we can do is always correct for it on state transition. So that's what I'm going to do for now as a first step. And you might see some issues pop up because of that, but yeah, I just want to go through with that. Is the attack frame hitting right before landing and the hit stop on the next frame cause it to go through the floor down? No, that shouldn't happen. Like the issue that we had before was that since the action state transitions occurred after a collision, the player would transition into landing, even though hit stop had been set, and they'd go into that landing animation and everything. But we solved that by moving the action transitions to before collision. So yeah, I'm not sure why that was happening. Physics shouldn't have been updated because physics doesn't update when hit stop is more than 0. But there might be something in the physics processor that's not checking for hit stop. I'll double check that here in a second. But I want to fix this for now. So we're always flipping on idle, but I actually kind of want to always flip on transition. For now. There are cases where you don't want to do that actually. So you know what we can do is, does Zig have default perimeters? Anyway, what I'll do for now actually is I'll go to where we transition to landing. So where do we transition for landing? We transition for landing and jump only, right? No, it's not just jump. It's also during attacking as well. That's true. So so we have handle ground collision. That's the function. So handle ground collision. So we have this whole thing transition to state. So what we can do is we can just flip. What is the back? Is there a back here? No, it's not a back. It's this. I always forget Visual Studio Code's controls. I don't need this comment here. It's kind of obvious what this is. So so this should fix the issue now. It doesn't fix the issue where you continue to attack will not cause flipping, but we're not going to worry about that for now. So you see how we auto correct now? That fixes that issue. So let's go ahead and submit that change. Oops. Okay, fixed an issue where characters would not flip to face their opponent on landing. Okay. There we go. Committed that, push that. Cool. Well, honestly, that's some good progress on stuff, and I think we covered a few common fighting game bugs that and potential solutions. I mean, we could talk a little bit more deeper about the solution I just carried out, which is to explicitly flip the character to face the opponent on landing. Again, this is a conditional thing. This function, it doesn't like force the character to flip. It only flips based on the direction. And actually, this is not the. Now I'm looking at it. This is not. It's a slightly a naive solution, right? It you know. So what we do is, what we are doing? Interesting. So we have this. It's been a while since I looked here. So it says conditionally flip the character to face the opponent if not already facing them. But the thing is, okay, I gotcha. So we made it a stateful thing. Typically, actually, I wouldn't do this. I don't even know why I did this originally. Maybe it was for convenience. But we have this facing opponent flag that's set somewhere. Set in physics, right? Sorry. Oh, wow. So honestly, this isn't great. I probably did this temporarily. So actually, let me talk about what the issue is here. I'm not actually checking the opponent's position relative to the character's position, right? The fighter's position. What I really should be doing is looking to see if the character's on the left or right of this character, and if the facing left. So if they're on the left, make sure that facing left is true. If they're on the right, make sure facing left is false. That's not what I'm doing here. I have this facing opponent thing that gets updated somewhere. That's not initialization. Okay, yeah. So I'm doing it here. So if the opponent is on the left, set facing left, and we're already facing left, then this is true. If they're on the right and we're facing right, not facing left, then this is true. That's what I'm doing here, and this is in the physics system. The issue is this here is that, well, there might be a reason, there might be some process in the game that puts the opponent on the other side after this physics update occurs, right? And in fact, like, this depends on the order of how the entities are updated. This depends on the order of when the entities are updated. So, for example, like, just say if player 1 moved to it was on the left side of their opponent, and then they moved to the right side during the physics. Well, it's fine, because then player 2 updates and checks to see, oh, okay, they're on my right now, so I can check my facing flag. But the problem was player 1 moved, and so player 1 moved during that physics check, and if that move occurs after we check for facing, then we have a problem, right? And in fact, the move does occur after the facing check. So what would happen is, you check to see, okay, yeah, the opponent is on the right here. Sorry, everything's probably going to be flipped. The opponent's on one side here, who's on the ground. I'm jumping over. And, well, so you check to see, okay, they're on the right. Oh, I'm facing them, that's fine. You jump over the other side. This frame, it's like, okay, actually, technically you're not facing them anymore, but the check already occurred. So that's bad. We don't want that. So we probably want to check the actual position of the fighter and their target when we do the flip, right? So I'm going to eliminate this facing opponent thing. We're not using it a lot of places anyway, so I'm just going to get rid of that. And replace the flipping function with this code, right? So can we jump to there? Can we jump to this code? Go to definition. Yeah, is that going to work? Yay! So we're going to want something like that here. The problem is, right? We don't have this we don't have the opponent's physics component, right? So not only do we need the physics component for this function, we need to have like the opponent's physics function as well, right? So we'll have to update this and update all the places where we get this, and hopefully have access to it. If we don't have access to the opponent, we'll have to expose it somehow. Yeah, I'll just go ahead and do this. So, well, the first thing to do, let's just update what this code is. So, I tend to just comment stuff out and then delete it, just so I keep it as reference. So, we don't care about the facing anymore. What we really do care about is whether or not you're going to be facing left, right? That's actually the thing we're checking. So, again, I'm just going to use this for reference. I like to retype everything now, so I don't miss something, right? So, facing left. So, what are going to be conditions for facing left? Well, so either the opponent's on my left and I'm facing left, right? Sorry, that's not right. sorry. So we want to face left, so we're going to face, the goal is to face the opponent. So if the opponent's on the left, we're going to face left, so that means the opponent's position is less than where I'm at. So first of all, we need that opponent physics. So opponent physics. We need their physics, right? So we have the opponent physics, and we want to say, okay, if their dot x is x, or is it position? Position dot x is less than ours. And actually, we don't technically have to pass in their whole physics component, but we're just gonna do that for now, for convenience sake. And my sense of symmetry. So either this is true, right? If we want facing left to be this, the opponent needs to be on the left side, right? If they're not, we want to face right. Otherwise, now if they're in this, so here's the tricky part. It's like, what do we want to do, right? Do we want to flip if we're exactly aligned with them, right? If we're exactly on the same position as them, what do we do? What do we do? We have three choices, right? Well, we could prioritize facing left, we could prioritize facing right, or we could do nothing at all, right? And just for the hell of it, and we could discuss the consequences of this later, we're going to say we're going to prioritize facing left. So what this means is if the opponent's on the same position as me, I'm just going to face left, right? So we'll do that. And that's what this will do. Okay, and we can check all this stuff, and I'll come back and delete this code once we're done. Just move this down here to, I don't need that anymore. Okay, actually, now we need to find all the call size of this function and update it so that we get access to the opponent's facing. So, and actually, I don't know if we've actually recorded a reference to our a reference to our opponent. Okay, that's a kind of an architecture change potentially. Is there anywhere we record per fighter, per character, what their opponent is? I don't know if we've even done that, right? Let me look at the initialization code. Where's our initialization code? Is it in game? Oof. Sorry, it's picking up searches in all the Zig platform related code I don't care about. Do we initialize here? I think we do, yeah. So right now we don't have like an opponent reference, right? I really want to cheat. I really don't want to cheat. But yeah. Where's our physics component at? I forgot where. Okay, hold on. It's all our draw code. Is it in our init code? Is that where it is? Create an init one character. Oh, here we go. Okay. So let's manually set an opponent. Where do we want to stick our opponent? Well, right now we have a physics component. Let's say our enemy. Enemy is easier to say. It doesn't sound like component. Opponent sounds like component. It's kind of confusing. So yes, say our enemy. So physics component, timeline component, reaction component, action flags component. These are the only components we have right now. These are pieces of our character state, right? Oh, actually, do we have more? Hold on. Set up reference component. Okay, this is for the action state machine. Got it. Okay. So what we'll probably have to do is create like a system that lets us pull down an opponent's or enemy's state so that we can actually check this stuff. So there's going to be a architectural change, and honestly, kind of zoning out here, so I'm going to save that for later. So we're going to come in and make that change next time I stream. Let's see, where's our notes? Is it notes? Not Zig notes, but planning. Yes, planning. So I'm gonna get back to the boring, annoying, boring stuff. So let's go to exactly what happened now. Okay, let's record what I've done. There's a bunch of stuff. I'm gonna put this in the backlog here in a second. So I have a bunch of stuff that's like backlog. Hold on. Because this is stuff I planned to do and I just never got around to, so backlog. Let's do that, backlog. Okay. So what did we do today? 2024 now. Today's the 18th? No, 25th, sorry. Okay. Yeah, so fixed an issue where keyboard inputs left right inputs were not okay, and the other thing we fixed an issue where like the left right inputs from the keyboard were not updated to match the player's facing direction. Armalex, what's up? What do you say? Hey Zenak, have you experimented with interpolating animations towards the post rollback state to smooth out artifacts? But the thing is, anytime you yeah, I've actually seen these kind of thing used, and the problem is like it can introduce latency in places you don't want, right? The choice is always latency or discontinuity, right? When it comes to rollbacks, you can either have an instant correction or you can have something fall behind, right? The only thing you can do is predict and get ahead of it, right? If you can actually predict what's going to happen, but the problem is with the way rollback corrections work is the reason corrections work in the first place or have to occur is because you didn't predict what was going to happen, right? Anytime you can predict what's going to happen in rollbacks, you won't see a correction. And when I talk about prediction, all I mean is, oh, well, the input we used, which is literally just the last frame of input, didn't change. That's what I mean by prediction, right? So, yeah, interpolation can smooth out the visual appearance of things, but what it does is add latency, because you always have to apply any input change later than the actual frame that occurred, right? Honestly, like, you could do it, but the question is, like, you have to empirically test to see, does it make the player feel a little weird about it, a little off, right? Because the thing is, everything's going to have to be delayed. You're always going to have to assume that you're going to need to interpolate, so, yeah. Oh, yeah, I mean, obviously, it won't be the true game state, right? That's going to be the issue. And, look, I think people are looking for looking to solutions for imaginary problems. We've already empirically shown that good rollback implementations are well more than good enough, right? I spent months hand testing and tuning rollbacks for Strive up to 300 milliseconds of ping. Like, as that game was being updated and changes were being made to characters and stuff, I was playing that game daily with 8 frames of latency. 8 frames of latency with 1 frame of input delay. So effectively, like 7 frames of rollbacks, right? Uh, I was doing this constantly all day for months and months and months, right? And just look, for the most part, you know, most games you're going to play are going to be less than 140, 150 milliseconds um, round trip uh, transmission time, right? If you're playing, honestly, if you're playing games with more latency than that, honestly, there's not much we can do because the experience is going to be so bad either way. If you add input delay, it's just going to feel like shit, right? If you add any other kind of latency visually or not, it's just gonna you're not gonna be playing a real game at that point, right? So like, look, the best thing we could do is direct you towards matches where you have a good connection with people. Um, and we do a pretty good job up to a certain point, right? We can do a pretty good job, if we allow the game to have up to 3 frames of input delay, people accept up to 3 frames of input delay, we can account for pretty much all matches online, right? The issue comes in with packet loss and jitter and instability, right? Rollbacks are amazing at accounting for jitter, accounting for packet loss. That's what they do a great job with, right? Because if we're talking about an environment where you use input delay only, what's going to happen is if you lose a packet, your game's going to stutter for the most part. Now, there's compensation for it, right? We include a history of inputs in both rollback solutions and input delay-based solutions to account for packet loss. But if you have a lot of packet loss, there's not much you can do with input delay solutions. If you don't have the input for that frame, you have to pause, right? You have to pause, otherwise the games are going to desync because you applied different input. You could potentially apply different input on the clients, and applying a different input on the clients means a desynchronization, and there's no way to correct for it on input delay-based solutions. That's what rollbacks do, right? They correct for applying different inputs on a particular frame. So they're amazing at dealing with like extreme packet loss and jitter. We're just literally input delay solutions don't have anything they can do other than pause and wait and see when the input's going to come. They can compensate and say, hey, if I'm seeing a lot of jitter, I'm seeing a lot of packet loss, the clients will wait, which is a terrible solution, a terrible experience for the player. And they can wait, and if they see the network environment has changed, they can apply even more input delay, which is, and you've probably all experienced this before. You probably saw, like, if you played like Exert or anything like that, you would see like your game suddenly super slowing down and maybe even pause for like a slight moment, and then you see the input delay shoot up, and now the game is like stuck in this shitty like underwater feeling, right? And never, sometimes the games do correct and go back down to shorter input delay, but honestly, you're not playing a real game at this point, so why even bother? And again, I think we've seen time and time again that rollbacks are good enough when implemented properly. I regularly play people on the West Coast, even East Coast of America, from Japan, in Strive and other games that have proper implementation of rollbacks, in Killer Instinct, for example. Killer Instinct's even better, like in the sense that it uses 3 frames of input delay, so it compensates for a lot more than Strive does, which I think right now they have it set for 1. My preference is games do give you the option to let you set your own input delays. So, say for example, I really want to play this guy who has like 200 milliseconds of ping with me. Maybe I should be allowed to set my input delay to like compensate for that, right? And talking about fixed input delay, I never accept variable input delay. It's You're not playing a real game at that point. You can't predict what's going to happen. And the kind of whole fun of competitive games is making predictions, right? And executing on those predictions and seeing if your guess was correct or not. And if you're constantly having like this like latency compensation code changing your input delay, then you can't make accurate predictions. Anywho, yeah, what else did we do today? Yeah, we fixed a bug where state transitions, let's say action transitions could occur on the same frame as a collision. So tack. So let's say okay, yeah. Okay, that's what we did today, and pretty much that's what we did today. I mean, I could check the log here. What's the commits? Oh man, we're almost down to 100 commit now. Woo! Okay. Oh yeah, we adjusted. Yeah, so you also adjusted the jump to feel less floaty. Okay, what else do we do today? Okay, yeah, and we also fixed an issue where characters. They actually, yeah, I did submit that, right? Yeah, yeah. Okay, that's great. That's what we did today. Sweet. What do we do next time? This is what I'm planning to do. Okay. I don't know what's going to happen. Probably not. Maybe not this month. Let's just say 2024. We'll update this later. So we want to make it possible to. Oh, say make it. No. Make it so that the what was the name of the function? Flip opponent. Flip to face opponent. Yeah. Okay, so make it so that the flip to face opponent function uses the current positions of the character and their opponent to determine the direction they should face. Okay, cool. That's what I want to do. Actually, do I have this in the yeah, let me update that updated planning document. Cool. Sweet. It's all there. And we can chill for a little bit. I'm no rush, but I'm not going to do any hardcore coding now. I think we fixed quite a few like important issues related to fighting games and discussed some potential solutions to common pitfalls, which I think that's a successful stream. That's a successful stream. Whoa, forgot about that already. Cool. What you what do I feel about Street Fighter 6 adding 1 frame of delay per 106? I don't like adding dynamic delay. I don't like games who determine to do that because, again, the point is, can you predict what the outcomes are going to be in a game? And if you're training to play this game competitively, you don't want unpredictable factors coming in, right? I have no control as a human other than picking my opponents, whether or not that extra frame of delay is added, which sucks. Really sucks. It's the same issue with having variable input delay. It's just that it's less variable, right? But it's still variable. Like, come on, dude. Like, I much rather would see corrections than have my inputs changed. It's not acceptable. In the very worst case, give the player the choice. I don't think the experience is so much better of adding like 1 extra frame every 100 milliseconds that even it doesn't matter, right? Like 100 milliseconds, that's round trip time, right? So divide that by 2, right? We've got 50 milliseconds. Well, how many frames fits into 50 milliseconds? Well, let's 50 divided by 16.667, whatever. Okay, that's about 3 frames. It's about 3 frames. If you just subtract 1 frame from that, that's now 2 frames. So if you only like look, so it basically for every 3 frames of network latency that was added, you're only accounting for 1 of those frames. So it's only 1/3, right? So pretty much where you would see 3 frames of correction, now you're only seeing 2 frames of correction. It's not that much better. Like, come on. That one frame is not going to make a huge difference unless their game has weird, like, huge changes within that one frame, right? Like, huge visual changes that could occur. And if those huge visual changes are frequent, maybe, but honestly, they shouldn't be doing that. They should be designing their game so that there isn't any huge visual changes that occur in one frame. It's one thing I really pushed for in Strive actually was like, hey, if you have any like sudden changes in visuals, don't don't do it instantly, right? Have the game kind of delay it for a few frames. It's not gonna be if it's like a cinematic, it's not gonna matter, right? It's already activated. It's already gonna start happening. So that those few frames of delay in triggering those big visual changes, it's gonna make a huge difference online. The other thing about Strive as well is all the camera. They may have changed at this point, but from the beginning of the game, the big idea was to have the camera always smoothly transition. There's never going to be any hard camera cuts, which is huge for rollbacks, right? Because the bigger the change that could occur, right, the more obvious those corrections are. If you're smoothly transitioning the camera every time, then you're not going to notice if that correction came in a few frames later during that cinematic, right? Well, the camera jumped a little bit, but not a huge amount. So, and honestly, there are ways to correct for that as well. You can just interpolate that camera. If it's a cinematic triggering, who cares, right? Like nobody's gonna notice the action's already started. uh, Armin Lex asks, um, my last question: what would you consider a good standard of rollback frames a fighting game should have? And for the projects you've worked on, you can disclose how many rollback frames you support. Things. Um, I'm guessing you're talking about the max number of rollback frames that are supported. Let's say like 8 or 10, honestly. Like, again, you don't actually want to be playing a game that has 8 frames of rollbacks, right? But if your game performance-wise can support up to 8 or 10, you're in a good place to compensate for packet loss and jitter, right? Those extra frames are just there as kind of like a buffer to prevent you from having to pause your game. Um, if if the network situation is so bad that you're hitting more than 10 frames of packet loss or additional input delay, additional network delay than you're having, something else is going wrong, and the game just needs to pause and wait for things to sort itself out. Luckily, with that much with that much buffering going on, right, with that much leeway given, you're almost never it's going to occur unless there's some extreme network situation, like somebody, playing on Wi-Fi and a microwave going off nearby or something, right? Um, Hypothetically, you could support even more if you wanted, but honestly, like once you hit past that 10 frame threshold, does it really matter as far as like quality of the game going on versus a pause versus like a correction, a huge correction, right? You're going to get a huge correction after that 10 plus frames. So yeah, I've empirically through testing we found that like probably 8 to 10 frames is good enough. And you just want to make sure your game performance wise can handle it, so you can do 8 frames. What it means is 8 frames of resimulation, right? 8 to 10 frames of resimulation in a single frame. So it just means that your game can perform its main simulation update 8 to 10 times in one frame. And I hope that's the question you're asking, Armalex. If it's not, I apologize. And you can correct me if that's the case. Yep. Yeah, guys, gals, internet pals. You know what? What about like an hour and a half here? I think it's a good chunk of streaming for me, considering I haven't done it for more than a year. I'm actually kind of surprised I'm not getting lightheaded at this point talking this much. I think I'll cut it off for now. And I appreciate everybody who's dropped by, and I hope you all can come by and watch more these streams in the future. Of course, I'm gonna upload this to YouTube. I'm gonna archive it. So yeah, let's do it again. See y'all soon. Have any questions? You feel free to hit me up on the Discord that we got, um, or hit me up on Twitter. I think I've been probably soft banned on Twitter because talking about the Musk man. But no, anyway, guys, gals, internet pals. I think I copied that from Kenji Lopez Alt or something. But anyway, see y'all later. Have a good evening, good night, depending where you may be. See y'all soon. Peace.